Okay. There you go. All right. This is Chem 1310. If you're here for a different class, thanks for joining us. I hope that you enjoy this. And I don't know. If you're here for another class, probably need to go to a different class. But it looks like everyone's here for Chem 1310. This is your first semester of a potential 2-semester sequence of a science class for basically for non-science majors. In the event that you need to take a chemistry class for science majors or something like that, talk to your academic advisor. But typically, people are taking the second summer session, they are in the class that they need to be registered for. I will be your instructor for this class. I will be recording this class. I kind of wanted to talk a little bit about the logistics and basically how this class is going to function. So we will be physically in person because this is a hybrid class. We will be in person for this first week of classes. So we have today, tomorrow, and Wednesday. Then we have a federal holiday, the 4th of July on Thursday. We will not be meeting then, but then we will again be in person on Friday. At any point during this first week, if you want to say, well, I'm just going to join remotely, that's your prerogative. What I'm going to do is a couple of minutes before our class starts, I'm always going to share the Zoom link because that refreshes or changes pretty frequently. I'll share a unique Zoom link for every day. I'll record the lectures and I'll post them on my YouTube channel and then post them on our Canvas page. So you'll always have access to those. That's one important part of this. After this Friday, everything will be on Zoom. So we'll not be meeting back in here. That's the nature of a hybrid class. It's like some percentage of the hours or some percentage of the class meetings have to be in person, and then the remainder are remote or not meeting in the same place. So we're fulfilling that requirement by meeting this first week. Now, at any point outside of this class period, if you want to meet with me to discuss either preparing for an exam or any of the content that we talk about, by all means, just send me an email. And that's to me one of the benefits of remote meetings. I've had office hours multiple times where people are clearly in their car, and then I'll say, hey, are you in your car? And they'll say, no. And then I will hear them driving over speed bumps as I hear that, or the dividers on the road. I'm like, pull over. So I'm glad to have office hours, provided that you're not endangering yourself or anyone else. Chem 1310, a little bit about myself with respect to this class. I'm Dr. Gray. I live here in San Marcos, married. I have 3 kids. They are Otis, Walter, and Arlo. They are soon to be 8, 6, and 4. The 4-year-old has just recently expanded his vocabulary to now say things like otherwise, which is very surprising and sort of strange. He doesn't really use it in the right context. It's almost like, I remember the first time that I learned lots of swear words, I would use them and it wouldn't make any sense how I use them. But now as an adult, I see that it makes sense wherever you use a swear word. Anyway, we went to the river a couple of weeks ago and it was kind of wild. My background, I was born, does anyone know that state? Nobody, that's the state of Wisconsin.
Is it?
It is, you're right, it's Wisconsin. It looks like a mitten. Why? Because it's cold there. I was born in Wisconsin. I was raised in College Station, Texas, however, because my family relocated. My parents had a bike shop and ski store in Wisconsin, and my dad liked selling bikes, but he hated selling skis. Said, you know what? If we don't live where it snows, I probably won't have to sell skis. Then does anyone know what this location is here on the far right? Bobcat Village Apartments. When I was an undergraduate here, I lived in the Bobcat Village apartments. I had a roommate. We lived together for 2 years. And as soon as I moved out, I never talked to him ever again. Not because we had any like angst towards one another, but we just did not vibe at all. But we lived together for 2 full years. So I got my undergraduate degree in biochemistry here at Texas State. Then I went to Texas A&M where I was a graduate student and I studied, this is a tomato leaf. And this tomato leaf currently is infected by a disease known as bacterial speck disease. So what I studied was basically how bacteria will infect tomatoes. And when you look at this leaf right here, it looks pretty sick and sad. Now, this is an example of a leaf that is a susceptible plant, or of a susceptible plant. So this is basically going to be overrun by this bacteria. What I studied was the tomato plants that are resistant to this bacteria. And so what they do is whenever they sense this bacteria, they cause a little bit of what's called localized cell death. And so they have these really small cell death lesions, but the entire plant can survive. And it was kind of a mechanism of like, I think that this is oh, it's not a write-up board, is it? Nope, it's not. Essentially what they would do is, here's some, I'm going to draw a very crude model of plant cells. So if this cell right here in the middle was infected by this bacteria, what it would essentially do is it would send out a chemical signal to all the adjacent cells. And it would say, hey, got bad news. Just been infected by this bacteria. You guys better kill yourselves. And so they would initiate this process known as senescence or programmed cell death. And so they would die. And the particular bacteria that I studied has to live off of live tissue. So essentially what it would do is to be like, okay, cool, I've infected this one cell. I'm ready to move on to other ones. But what's the state of these surrounding cells? They're all dead because they received that chemical signal of initiated cell death. So they would all be dead. So this bacteria would effectively be trapped in that one cell. So it would get to one and be like, ha ha ha. And then all the adjacent cells would be like, nope, we're dead. Can't do anything with this. So I studied how plants respond to bacterial pathogens. So I got a degree in biochemistry. And since 2013, I've been here at Texas State teaching. I've taught this class, then I've taught at the time it was 1430, but the follow-up class, if anyone has to take 6 hours, they'll take 1310, and then lots of people take 1330. So I've taught that class, I've taught this class, I've taught biochemistry classes, general chemistry classes, and there you go. I did a Google search for chemistry meme, and here's what I found. This is, I think it captures what I find to be really interesting about chemistry. So this right here, Na, found on the periodic table, right here, as an element. Does anyone know what this element is? Sodium. So sodium takes one form where if you throw it into a glass of water, it's going to react very violently. And it's basically going to ignite. And it's going to throw it in water, and lo and behold, it's going to violently react, and you'll see kind of flames produce. Or if you put it into like a container, it's going to burst. So sodium can react very violently and cause that to take place. What about Cl? What element is that? Cl is over here with an atomic number of 17. That's chlorine. Now, chlorine as a gas was used as a chemical warfare agent in World War I. So chlorine has its kind of capability or ability to be very violent and deadly. So sodium and chlorine, they can both be dangerous. They can both be deadly. However, they can also be used in combination and in different forms than what are displayed here. Make a compound known as sodium fluoride, or simple table salt, make a steak taste better, or broccoli taste better. So this is one of the things that I find really interesting about chemistry, that in one form, something is very violent, potentially deadly, and then in a slightly different form, the same substance doesn't have that same effect. And yes, you could make the argument, oh, well, what about hypertension and high blood pressure? You're not wrong. But if I get table salt and I put it on my tongue, it's highly unlikely that my tongue is going to burst into flames, so I'm going to be dead. However, if I get sodium in its elemental form, one specific form, that's potentially catastrophic. So that's what I find to be kind of interesting about chemistry, and those are some of the things that we're going to talk about in this class. Now, schedule. And I apologize if I'm kind of all over the place. Day one for me is always kind of funky because I'm like, oh, well, I gotta talk about this, but we already talked about this, talk about this first. So if at any point you say, I'm confused, don't hesitate to let me know or ask. So our campus homepage has the day-to-day plan, and that is displayed right here. The way that I structure the Canvas page is, as the semester progresses, you will have to scroll down. I don't use the Canvas app very often, so your display might be a little bit different. But if you visit this on in a web browser, this is what you should see. So Chem 1310, here's our schedule. I've got it set up in a matrix or in a grid. There's our day, the date of meeting, the suggested reading. That suggested reading, those are hyperlinked to our textbook. So do you need a textbook for this class? No, you don't. I'm going to be using an open educational resource from this kind of big consortium called LibreText. So it's lots of different science books that people have kind of collectively authored. And so I'm going to be using that. So anything that I ask you to look at or suggest that you look at it in advance of a quiz or exam or something like that, go to those links. In addition to that, that's what I'm going to be building PowerPoint presentations on. And we'll talk about it in a day-to-day class period. It's going to be built off of that. Now, is it absolutely essential that you read versus come to class or versus watch the lectures? That's kind of a toss-up. I think that anytime you get exposure to content more than one time, you're going to have a better understanding of it. I personally, if I were in this class, what I would probably do is I would go to each one of these different sections and say, okay, what's the big umbrella topic here? Okay, classification of matter. Okay, well then it has physical properties, chemical properties. Okay, cool, that's what I should anticipate. Maybe bolded terms, what's the definition there? Okay, that's what we're going to be talking about. And then if after the class you're like, I'm going to revisit that, or that sentence didn't make much sense to me, I'm going to see if it does now. I think that would be a good strategy, a good approach. I'll post our lectures in both PowerPoint and PDF, and then in this cell right here, or in this column right here, that's where I'm going to be posting the links to our lectures. The next is going to be a quiz or activity for the date. And if you look through this, what you'll notice is that we've got lots of quizzes. And I hate the term quiz. I also hate the term homework. That's actually one of my criticisms that I received on my Rate My Professor. He doesn't use homework. You're right. When I was a student, I hated homework. And I don't really like it much better now. I understand the value for it. I'm not defining these as homework because of the fact that there is a set time frame. These quizzes, I hate the term quiz because I know whenever I would have a class, I'd be told, oh, you got a quiz on Friday, and I'd be like, oh crap, I got a quiz, it's stressing me out. And then the time whenever I'm going to take it, I'm kind of anxious about it. But until I find a better word, we're going with quiz. These activities, I think that it's valuable to think about them as primers for the exam. I always like to think about the questions that I put in here as kind of what is it? What's the term? Cutting room floor type of exam questions. So let's say that I'm going to write our exam for this first block of material. No, I'm going to get rid of this question, this question, this question. Why? Because I wanted to pare the exam down to a certain number of questions. Does that mean that these questions are no good? No, it doesn't. It just means that I elected to not use them on the exam. Now, will these help you on the exam? Absolutely. So take these quizzes. They are, this first one is sort of an outlier because you do need to use Proctorio. So you will have to have a webcam and basically whatever you're going to be using for taking your exams, you'll have to use for this first exam or for this first quiz, just kind of as a test or a pilot run. All of the other ones, I'm not going to administer with Proctorio. So these quizzes, what I've termed quizzes, they're open resources. That's why I said that they're not really quizzes, they're not really homework. They have a set time frame. You can look through your books, you can look through the PowerPoint or anything else while you're doing it. It's not a concern to me. Does that make sense? Okay. They're going to be short. They're typically going to be 4 or 5 questions. And I think that I've allocated 15 minutes for y'all. And that's just to have it as like, get it done. You won't get a grade until they've actually all been submitted. And you'll have 2 attempts at these. So but the questions are effectively the same. So when you look at it the first time, take notes for yourself and say, well, this question I split between these 2 different options. Which am I going to go with? We can kind of game it that way. Does that make sense? Okay. So here's our schedule. Every Monday, we're going to have an exam. Those exams are administered with Proctorio online. So that's the lockdown browser. I really want to make sure that with this very first quiz that you don't have any sort of technical hiccups. In the event that you have a technical hiccup with Proctorio, you need to contact ITAC. And what I would recommend doing is I would call them, just because if you email them, then they're going to make a ticket for you. And then they're going to email you and say, hey, a ticket's been created for you. And we'll get back to you in this time frame. And they act very fast. But for your exams, for instance, I'm going to give you a 4-hour window in which to complete that exam. And if it takes them 3 hours and 20 minutes to get back to you, maybe that falls within that window. So what I would do is I would call them. One of the things that I would also advise you to do is not email me in hopes that I'm going to be able to fix the problem. And what I'm not trying to sound like cold, and don't email me, even though I know the words that I just said were don't email me. I understand the irony there. But if it's a technical issue, if it's an urgent technical issue, email or contact, or I would call ITAC immediately. Because if you email me, then I'm going to say, or chances are what I'm going to say is, oh, it sounds like you should contact ITAC, because that's what I do whenever I encounter technical issues. So I want this first run with Proctorio to be kind of a test run of sorts. So if they recommend that you use Chrome as opposed to Mozilla or Edge or whatever web browser. So you'll resolve that as soon as possible. This very first quiz opens today. If I remember correct, it opens today at it opens today at 12 and it closes tomorrow at 2 p.m. And that's, that gives you 26 hours to complete it. And that's what you should expect for your quizzes. You're going to have 26 hours to do them. And so just so we're on the same page, I think that I'm a reasonable person, which is what all unreasonable people say. But if you email me tomorrow at 1:45 and you're like, oh, I didn't have a chance to take my quiz. Well, then I'm gonna say, we'll take it right now. Or if you email me today and say, I have to work tomorrow morning, I can't take my quiz. Well, what happened to the day that just passed? I would say just knock out the quiz as soon as possible, so then you're done with it. And I don't, yeah, so that's what I'd recommend. If there are extenuating circumstances, we'll talk about it, but for the time being, I would just recommend that you get to your quizzes as soon as possible. Okay, sure. So there's our homepage. It doesn't like auto scroll or anything like that. So if you want a specific date, you gotta scroll down. We're in person today through Wednesday and on Friday in this room. Everything else is going to be on Zoom or YouTube. Kind of your prerogative there. All lectures are going to be recorded and posted to my YouTube channel and Canvas, as I mentioned previously. Communication. I post almost everything as a Canvas announcement. It's pretty uncommon for me to email you directly. I do reach out to students around the drop deadline or a little bit before. If someone misses the first exam, I'm going to email and say, hey, you missed your first exam, or you haven't done anything in class. Are you actually taking this class? But typically I like to use announcements just because it sends the same message to everyone. Office hours by request, and I would say the easiest are right before or right after lecture. I have two pretty standard messages that I get, and the one that I highlighted in green I would say is much more effective, and that's, hey, Dr. Gray, I've got some questions about our upcoming exam. Can you meet on Zoom at 1:30 on Friday the 5th? Yes. That's helpful for me because you've narrowed down a time, so this is when I'm available. What's less effective for me is, hey, Dr. Gray, I need office hours. When can you do office hours? I understand the question, but this is where I want you to like take control of your life and take command and say 1:30 Friday. And you know what I'll say is, okay, yeah, that works for me. Or no, that doesn't work for me. How about an hour later? So then we're starting conversation about when to have office hours. So I don't have set office hours, but like I said, right before or right after is pretty darn convenient for me, because then it's just, hey, stay on the Zoom for me. And I'll say, sure thing. And in the event that it's something that you want to ask in private, I'll say, okay, and I'll open a Zoom breakout room for you. And I'll send you in there and then I'll go. So those are the best ways to communicate with me. Grading. We have quizzes, lots of them. They account for about 20% of your grade. So there's something that, like I said, they're open note, but they have a time frame. So take your time with them, but know that you have a second attempt at each one of them. The highest of the two grades is what's going to be used for your grade calculation or for that weighting section. We have 4 regular exams. They're going to be administered on Mondays. So we have our first one this upcoming Monday. Now, your final exam can replace replaces lower exam grades. I've always been kind of at odds with, let's say hypothetically, I think everyone's sort of had this experience in a class where, let's say your first exam, you don't do so well on, and then, well, here. An example of what grading might look like is first exam, somebody gets a 55. Second exam, third exam, fourth exam. They get 80, 85, 90. They kind of figure things out. They're like, oh, now I understand the way that he likes to ask questions. I'm going to amend my studying style. Each one of these exams is worth 15% of your grade. Your final exam is also worth 15% of your grade. So 4 times 15 for exams 1 through 4, that gives us 60%, plus the final 75%, plus 5% for participation, which are going to be polls and other kind of in-class activities. And quizzes, that gets us all to 100%. Now, what I've adopted in the past few years is a more progressive grading scheme. I think most people have the experience, I know I had the experience where it was like, oh, your final replaces your lowest exam grade. It's like, oh, okay, yeah, that feels good. But there are always circumstances where maybe you miss 2 exams, in which case, you know, maybe you broke your leg on the second exam. The first one you just didn't do too well on. The third and fourth you did great on. And so the one that your final exam replaces where you broke your leg. It doesn't replace your first exam. Sorry, it's tough. I've always kind of had issues with that. So in the past few years, I've adopted a more progressive style of grading where your final replaces anything that's lower than the final. The rationale there is this final is a cumulative exam. So let me ask you, does it have content from exam 1 on it? Yes. Does it have content from exam 2 on it? 3, 4? Yes, it does. And it's pretty evenly distributed. Now, the first time that you saw the exam 1 material, you got a 55 on it. But then as the semester progressed, things started to click. You're like, oh, I didn't understand that because of this. Now I understand that better. Exam 2, you did better than exam 1, but you still had some gaps. You filled those gaps in. And by the time the final rolls around, your understanding of that material is better than it was when you took the exam, that exam number 2. So effectively, your final exam can replace every single exam as long as that exam is lower than what you did on the final. I'm not going to do anything particularly punitive, like, oh, yeah, your final, you got an 88, that's going to bring you down a little bit. No, I kind of look at this as it's an opportunity. Your final is an opportunity for growth. Because I know that genetics in particular, I think we had 3 tests in there, maybe 4. And my first 2 I did not do well on. Your final could replace 1. And I remember just being like, even if I got like a 130 on the final, which was literally impossible, the highest grade I could possibly get was a C. And so then it was like, well, there's not much of an incentive for me to aim for that impossible grade of 130. And I was like, this just sort of sucks. It was like, barring a total catastrophe, I wasn't going to get lower than a C. And there was no mathematical way for me to possibly get higher than a C. And it just put me in this position where I was like, this is dumb. I have to take this exam that I'm going to do math on, and lo and behold, how did I do on that final? Math. And what did I get? C. But you know, C is for complete. So there we go. So that's, I like this grading style because I think that it gives students a better opportunity to improve and more of a reason to try as the semester progresses. Anytime that I introduce this, or anytime I show this, I do always recognize and bring up, there might be someone in here who's like, aha. So if I skip exams 1 through 4, and then I take the final, and I ace the final, that replaces exams 1 through 4. And I think, yeah. And I'm not issuing that as a challenge or anything of that. Is that a foolish way to do things? I think so. Because you've kind of missed the point of education. And, you know, this is here to, you know, to take an exam and make a mistake. And then be like, okay, well, I can correct that mistake when the final rolls around. To take another exam and be like, you know, I thought that I understood this in this way, but it looks like I need to tweak my understanding. So that's what this is all intended for. I have yet to have someone, and I've done this in 5 different classes. I did have someone who was like, they did not take any of their in-class exams. And what they also did in that case was they did not do any of our quizzes. They did not do any of the participation. So then it was like super savvy to come up with this calculated way to get an A in the class, but because you missed everything else, the highest you can get was like a 75. And that person got like a 25 on the final. So I don't know if what their plan was. If there was a plan, I think that might have been the problem. There wasn't a plan, but it didn't shake out as as I think they thought it was going to. Okay, so initially exams are going to be administered on Proctorio, so you need to have a webcam to be in compliance with security standards. And I say initially just because in the event that something like there's a technical issue, like, oh, I need to modify this, I will, and we'll do something different. I did Proctorio previously and I was fine with it. There will be, the questions that I will give are a mixture of multiple choice and multiple answer questions. And usually your exams are going to be about 25 to 30 questions long. Now, multiple choice questions are A through E or A through H or something like that. And there is one correct answer, or there is one best answer. Multiple answer questions, by contrast, are a little bit trickier. Now, multiple answer questions are trickier because you have to, you typically have to remember like, oh, what are the 3 facts about this principle or this phenomenon? Well, if you get one of them, select one of them, you'll get partial credit. If you select two of those 3 things, you'll get partial credit. If you select all 3, you'll get full credit. So it's kind of a return on, if you know half of the information, you'll get half of the credit. One of the things that people don't like about multiple answer questions is that they are more challenging. Another thing is that if you remember one fact and get one of those, select one of those answers and get credit for that, and then you're like, ooh, I think this other one might be right, but as it turns out, it isn't. The way that I sum up multiple answer questions is they are 1 step forward, 1 step back. So if there are, let's say there are 2 answers and you select one of the right answers, one wrong answer, you do not get partial credit for that because your partial credit was erased by your incorrect other answer. Does that make sense? So my advice when it comes to multiple answer questions is err on the side of conservatism. Be a little bit more conservative and be like, ooh, that's the one that I know for sure, so I'm marking that one. These other 2, I could flip a coin. I'm not really in a gambling mode today, so I'm just going to move on. The breakdown is usually about 1/3 of the questions are multiple answer questions. The other 2/3 are going to be multiple choice questions. Does anyone have any questions about the structuring of our class, how we're going to cover content or anything like that? Your first assignment is today. It's that quiz that gets posted today at 12 p.m. And yeah, deal? Yes.
Are the exams after quizzing for the open house?
No, thank you for asking. The exams are going to be closed out.
Okay.
So, great question. Yes.
So the quiz that we're gonna take tomorrow, we're taking that in class, you want us to take that before?
Take that, everything online. So great question. So that one, it opens today at 12 p.m. You have until tomorrow at 2 p.m. to complete it. I know that if you look at the week calendar, it's a little bit confusing, and I'm sorry for that. I'm sorry. It shows up on Tuesday, but it's also available today. Where does it start? Where does it end? That's kind of where I was. What do I do? So I liked it to go with that. Yes.
So the quizzes are online outside of class and the exams are in class.
No. The exams will be online as well. They're just not going to be open note. So the first quiz will kind of be similar to what your first exam will be like, because we'll be using the Proctorio software. So that's where I'm kind of pushing everyone to figure out technical issues that they may encounter. And think about it as like, because it's gonna have you walk through this, like scan the room, survey the room to make sure that there's not like a secret test taker in the room with you who's like, it's A. So it will be similar to that.
And then the quizzes after this quiz, they're all gonna be on Friday, maybe after Monday.
No, I'm sorry. The quizzes are going to be throughout the semester, so we'll have. The difference of the quizzes is that we're not going to be using Proctorio for the quizzes after this first one.
Yeah.
So this first one is just like use Proctorio to get comfortable with it. And then you can see there's basically a quiz every single day.
Okay.
And you got 26 hours to do it.
With the exams, is it during like, you said it's like 4 hours, is it during the lecture time?
Yes, so what I was thinking was, and if anyone has any conflicts with this, please let me know and I'll try to be flexible. Basically like 9:30 in the morning, because our class starts at 10, goes until 11:30 or 11:40. Probably about 9:30 until about 1 p.m. That's going to be the window of time in which you can take your exam. The exam's going to have like a 60-minute, time frame for it. Which if anyone has accommodations, email me, if you're gonna take your exams at the testing center, by all means. But if you're not, email me and then I can go into Canvas and adjust the duration of your exam. But yeah, it's going to be, here's the window that you have to take it and you have 1 hour to do it. So what that means is if you're like, well, my exam, I'm gonna start at 9:45, then your exam will stop at 10:45. Now, one thing that I want to caution everyone about is if, let's say it's 9:30 until 1 p.m. If you get on at 12:45, the exam will close at 1 p.m. So you will have only given yourself 15 minutes. So that's one of the things I want to caution everyone about and against. And with all that in mind, there's a couple other things that I wanted to mention. If you miss an exam, like if you're ill or something like that, or if you get on and you just run into problems, what I would do immediately is, like I said, call ITAC, because if they can resolve the issue, one issue that people have had is Proctorio. It kind of commandeers your browser. And Proctorio manages an access or like a password. I'm not going to give you a password, but Canvas will say, it might prompt you and say, your professor probably gave you a password. Enter that password here. That's untrue. Chances are what you have there is you have a pop-up blocker that has blocked the Proctorio pop-up, which that Proctorio pop-up enters your password. So Proctorio manages the password. So in the event that you contact me and you're like, hey, it's asked for a password, that's Proctorio's managing. And that's probably a pop-up blocker or a web browser issue. That's not going to block you from taking the exam, so long as you try using a different browser or something like that. So really, whatever problems that you encounter today, should you encounter any, if you don't make a change, you'll encounter the same ones when we take our first exam. So what I would do, that's why I want to do Proctorio right off the bat, so we can kind of, if we encounter any issues, we can get them resolved. So you're like, oh, I'm going to take my quiz at the library. Great, take it at the library. Then I would plan on taking all of my exams also at the library, just so then you can kind of have that test that was passed. Make sense? If anyone has had, I had a student who contacted me last semester who their computer was stolen. There are plenty of computers at the library that are in compliance with Proctorio. In addition to that, you can do like day-long rentals of like a laptop from the library. You just go to the circulation desk on the, I guess it's the second floor, the floor with the Starbucks, the main floor. Second. Okay. My office is on the first floor of the chemistry building, and everyone refers to it as the basement, which I feel like is I take that personally. But my office is room 123, so I'm actually on the first floor, so I'm number one. Everyone needs to realize that. But does anyone have any other questions?
That's when there's no lectures on the test days.
No, there are not. Test day is the test day. That's also a very good way to lose every single popularity contest ever, and that is by saying, hey, after we take our test, let's talk about this, just to make sure that you're feeling pressure. Okay, so if you look at our schedule, we're covering really not more than, I think the most that we cover is maybe 4 sections from the textbook in a given day. We're gonna start out 2 today, 3 tomorrow, 4 the next day. Don't get overwhelmed with them. The volume of content that you're going to be seeing should be comparable every day. We have things are kind of categorized into like a block, because you're never going to have a day where it's like, hey, here's section 1 from chapter 7 and section 2 from chapter 5, putting your brain in 2 different places. We're not going to do that. So today what we're going to talk about, or we're getting into chemical and physical properties. Okay. A physical property is a characteristic of a substance that can be observed or measured without changing the identity of the substance. This is a hefty sentence, and one that I think that you definitely have to process for a little while. And what I always try to do is whenever I see something technical sounding like that, I try to rephrase it. And so the rephrase that I came up with from that was, a physical property is a trait of a substance that can be seen or measured without altering that substance. So you're not changing something, but you can observe something about it. Now, a physical property is something that, well, there's a couple of major physical properties. So when you see something, you can kind of describe that something with a physical property. For instance, the color of something is a physical property, because that's a visible physical thing. The hardness of something. Now I know that you can quantify hardness of wood, for example, or hardness of materials. So hardness is a physical property. Does anyone know what malleability is? I'll give you a hint. Gold is very malleable, or is highly malleable. Shiny is a good one, but not quite. Exactly, the international symbol for malleability. Yes, hand motions, it bends. It's a nice technical word for bendable. Solubility is a physical property. Can anyone think of an example of something being soluble or insoluble? Salt water. Salt goes into solution. Salt is highly soluble. One example that I always like to think of when it comes to solubility, has anyone ever had gotten a shaker bottle and put whey protein in there? A trait or a quality of a high quality whey protein is it goes into solution very well. So then you can drink it and you don't get like weird clusters of powder and then start coughing after drinking it. So the ability of something to go into solution, its solubility, is a physical property. The ability of a substance, whether that's a solution or a solid, to conduct electricity is a physical property. Then melting point, boiling point, Water, I think, serves as a great example of that. The melting point of water and ice is about 32 degrees. The boiling point is about 212 degrees. Now, one that I skipped over is density. Does anyone know what density is? Now, I feel like most often when people are thinking about density, it's something that they'll be able to identify and be able to describe a substance as being dense or not dense. But when prompted with the question that I prompted y'all with of what's density, it's a little bit like, whenever I think of density, personally, what I think about is, let's say that you got a coffee cup and you put that into a body of water. What's going to happen to that coffee cup? It could be, and key is that it's empty. It could be a paper cup, styrofoam cup, doesn't matter. What's going to happen to it? It's going to probably float. It's going to be buoyant. It's going to stay at the surface. Now, let's say that instead of it being empty, I get some sand and I fill that coffee cup with sand and I put a lid on it so I can seal it off. What's going to happen to that sand whenever I put it in, a sink filled with water? It's going to sink. Now, if you think about that coffee cup as one thing, whether it has the sand or it doesn't, when you added the sand to it, you increase the mass, you increase the density of that substance, because that coffee cup, the amount of space that it occupied, the volume that it occupied hasn't changed. But when you added the sand to it, you added a bunch of weight to it. Does that make sense? So density, which we'll get into a little bit in the future, density is a physical property where you're looking at something and you're thinking about what space does it occupy, what volume does it occupy, and how much does it weigh? Something can weigh a lot, but not occupy a lot of space. That's something that's very dense. Whereas, I think whenever it comes to density, I always like to think of examples of substances that are very dense or not dense. I think about a cinder block or just a regular old brick versus a styrofoam brick. Now, a block of styrofoam that's the exact same size as any brick that's used to build a house, well, I can throw that into a body of water, it's going to float. If I get a brick and I throw it into a pool, straight to the bottom. They're going to occupy the same space, but one of them is heavier. And it's that combination of weight and space that it occupies that cause them to be different. So these are basically a list of 8 good physical properties. Now, like I said, density. Density has units shown here as grams per centimeter cubed. Now, before we get into these individual values, whenever you see this CM3, that is supposed to be CM raised to the 3rd power. That is a cubic centimeter. Has anyone ever watched a TV show or a movie where it's a hospital or ER setting? Someone's going to shout out, oh, we need 1,000 cc's of blah. Does anyone know what that cc is? It's a cubic centimeter. So with that in mind, and we will get deeper into this later on, but whenever you hear cc, this is the same as a milliliter. So a milliliter, if we look at this bottle of drinking water, it's 500 milliliters. This has 500 cc's of water. Now, one of the things that I always do also whenever it comes to centimeters cubed is I kind of visualize a cube. And whatever you think about the area of a cube, doing one of those calculations from like a geometry class or something like that. What are the dimensions that you care about for a cube? Care about the length, the width, and what's the last one? The height. So you have 3 dimensions. How long or deep this cube is, how wide it is, and how tall it is. So this would be, if each one of these sides was 1 centimeter, this would be considered a cubic centimeter. Does that make sense? So that's a volume. So when we look at density, the units for density are grams per centimeter cubed or grams per milliliter. Now, when we look at all of these different densities, we take something like, let's go with, I'll use honey versus water. Water has a density of 1.00. So I'm gonna write water. Water has a density of 1 gram per milliliter. Honey has a density of 1.42 grams per milliliter. Has anyone ever added honey to like tea or just straight up water? What happens to that honey? It goes to the bottom, it sinks. Why? Because it is more dense. It has a greater density, so it sinks. So anything on this list, what I'm going to do is or what I recommend doing is looking at this list and thinking about it as compared to water. Is this thing going to sink in water or is it going to float in water? Because when you do that, then you can kind of exchange these things a lot. So if you had body fat or corn oil or mayonnaise, and you added each one of those, and let's say that, mayonnaise, well, all of these are kind of tricky because if you add it into the water, what's going to really happen is they're going to mix in. So they're going to make one solution. But let's say that you got a dollop of mayonnaise and it didn't mix with water, but you added it to water. What do you think is going to happen to that mayonnaise? Given that mayonnaise's density is 0.910 and water's is 1.00. It's going to float. So if you're thinking about, I'm going to make a boat out of a food material, mayonnaise is a good option. But it's also not a good option because what's going to happen to mayonnaise is it's just going to fluid off. It's going to be gross. And I don't think anyone's ever built a boat out of mayonnaise successfully. I don't know that anyone's ever tried, but if they have, it probably doesn't work. So something with a density lower will float, something with a density that's higher is going to sink. Now, I would recommend always comparing it to water, but then you can compare things within this list. So if you had a glass that was filled with corn oil, and to that you added milk, whole milk specifically, what's going to happen to that whole milk? Well, it's going to sink to the bottom because it is more dense. But of course, then it's complicated because you got to account for, well, what's in greater abundance? I'm talking about if you added a couple of drops of whole milk. What's going to happen to those drops of whole milk? They'll sink to the bottom of that corn oil solution. Does that make sense? Okay. So density is one of the physical properties that we're definitely going to focus on and bring up quite a bit. So physical properties, they're very great at describing a substance and how it doesn't change. Chemical properties, and this is from your textbook, a chemical property of matter describes its potential to undergo some chemical change or reaction by virtue of its composition, as well as what elements and electrons are present to give a potential for chemical change. As soon as you put a sentence, or as soon as in a sentence you use the word virtue, I immediately get distracted. I see that word and I'm like, what's that one mean again? And I will have to pause and then I'll catch back up. Complicated sentence here, but what does it say? The key of this sentence is potential. So the potential of something to react, based on what? Based on electrons and bond that are present in that substance. A more simplified version of that sentence is a chemical property of matter indicates its ability to undergo a chemical change or reaction due to its composition. Okay, so if we were to stop right there, that's a good place to stop and pause. So basically, ability to change or react due to its composition, whatever that substance is made up of. And within that composition, we have to account for what elements, electrons, and types of bonding is present. Now, when we were talking earlier about sodium and chlorine, elemental sodium, a single atom of sodium. Well, that single atom of sodium, the only element that's present is sodium. So really what you're not concerned about bonding that it has established with anything else. Instead, you're much more interested and curious about what electrons or what does that look like at an atomic level. Now, chemical properties. So the ability of something to undergo a change, typically, whenever you talk about something undergoing a chemical change, good words to look for are something burns, something rots, something explodes, decomposes, or ferments. Has anyone ever made kombucha or drank kombucha? Well, kombucha is a fermented tea. How do you make kombucha? Well, you get tea leaves, you get boiling water, you add some sugar. And then you also basically let ambient bacteria form and grow. Now, one of the important parts about kombucha is that it has to ferment or incubate for like 2 weeks. If you got that tea, and let's say that you got tea and you got a bunch of berries in there and you mashed them up and you drank it, it's going to taste like tea with berries in it. If, however, you let it incubate for like 3 weeks, it's going to taste like what an armpit smells like, because that's what kombucha is. It tastes like what an armpit smells like. I'm sorry, that's a gross description, but every time I open one of those bottles, but it's from my gut health, so I better drink this. I don't know if it's at any rate. These are terms that you definitely want to look out for on exam questions. Now, with these in mind, one question that people always love to ask about chemical changes and chemical properties is, let's say that you got milk and you left it out. You sat it outside for, let's say, 2 days. What's going to happen to that whole milk? It's going to curdle. It's going to get gross. This is tricky because lots of people will see that and they'll be like, well, it's still milk. It's just now more of a solid. And so that is a physical change. But that's not the best explanation. What has happened to that? Well, another way to think about it is if somebody gives you a glass of water, that's safe to drink. If somebody gives you an ice cube, that's safe to chew on, right? Because it's water. One of them is colder than the other. Okay, now let's take that milk example. If somebody gives you, and let's imagine that you like drinking milk. If somebody gives you a glass of milk, you're like, okay, I'll drink that. And then somebody comes along and say, and I've got this glass of milk that sat outside for 3 days. I've increased the time just to make it more gross. It sat outside for 3 days. It's just a physical change. Are you going to believe that person who says that it's just a physical change? No, because one of the things that you can also do is you can pick it up. What's going to be different? Aside from like the visual, are there going to be other supporting details that you pick up on as you get that closer to your face? Yeah, it's going to stink. What has happened is that milk, we don't really use this term for that, but it's effectively rotten. It's undergone chemical changes. So that milk has lots of proteins in it. Those proteins have done what is called, they've misfolded. And That's why that milk is now sour and smells awful. And you don't want to drink it. In part because you wouldn't be able to drink it, you probably have to chew on it, which makes the idea of chewing on soiled milk even more gross, chewing on milk. Okay. So rotten milk is one example of a chemical property. Iron rusting or iron metal rusting forming iron oxide is an example of a chemical change because iron Fe on the periodic table right here, number 26, reacts with the oxygen in the atmosphere, reacts with water. It forms a compound known as iron oxide. So it was just Fe, now it's FeO2. So the chemical composition of that iron has changed because it's reacted with something in the environment. Another pair of examples, well, green banana turns yellow whenever it ripens, then subsequently turns brown as well as when it continues ripening. A dry piece of paper burns. Well, paper is made up of cellulose extracted from trees and wood sources. And then whenever something burns, we'll get into this later on in the semester. When something burns, when a carbon-based substance burns, it turns into CO2 and water, CO2 and H2O, in what's known as a combustion reaction. So it has changed its chemical makeup. It's physically changed and it's chemically changed. But a better description of paper burning is that it's a chemical change. Now, physical properties, well, gallium has a melting point, 30 degrees. Gallium goes from a solid to a liquid at 30 degrees Celsius. Mercury is a very dense liquid. Gold is shiny. These are all physical properties. Gold is shiny and it's also malleable, it's bendable. Okay, good. Does anyone have any questions about those? All right, fantastic. Physical changes. The hallmark of the physical change is that no bonds are broken or made. An ice cube melts. The shape of the water changes, but it's still water. Separating components of a mixture from one another. If you've ever been down in like Texas City or Pasadena or anywhere that there's lots of oil refineries, they have these really tall towers. Does anyone know what those are? Crackers. They're for fractionation. So it's like you get crude oil and you heat it up, and that crude oil is going to separate into kerosene, jet fuel, and gasoline. Why? Because they all have different melting points. So those are physical separations. That's taking a mixture like crude oil and heating it up a little bit, getting one thing to separate off, then continuing heating it to get another thing to separate off. So separating a mixture, the oil and gas industry, separating mixtures is a huge part of the oil and gas industry. Making a solution, so getting something to go into solution is a measure of solubility. A physical deformation, if something gets cut or if it gets dented or if it gets stretched, it's still a physical change. Chemical changes. In a chemical change, well, the opposite is taking place. Bonds are broken and or formed between molecules or atoms. There are observations that you can make if you watch something that indicates a chemical change is taking place. Now, this first one is a little bit tricky. Temperature changes, okay? Now, what I want you to think about is in probably December or January, you go to like Academy, Sports and Outdoors, or sometimes at HEB or the gas station, you'll see those warming packs. Does anyone know what I'm talking about? They look like little Kool-Aid packs, really, but then you open them up and it's basically these little things that you put in your gloves. And what you do is you twist them, and it's two different chemicals. And what those chemicals will do is they'll mix and they'll produce a huge amount of heat. So you can put them in your gloves and now your hands are going to stay warm. So those are warming substances that a chemical reaction is taking place that is causing a temperature change. Does that make sense? I'm not saying like, oh, when it goes from 90 degrees, when you're outside and it's 90 degrees, but it drops to 85 degrees. What are the things that you see? Instead, what causes something to undergo a chemical change or a temperature change? If light is produced from a reaction, for instance, if you think about fireflies produce a small amount of light. That's because of the chemical reaction that's taking place in their, not an entomologist, body. So that's what I'm gonna go with, because bugs have bodies. A color change. Again, let's go back to that milk. If you leave it for long enough, what's gonna happen to it? It's gonna get kind of green or yellowish. If you get a steak and you're like, ooh, I got this discount steak, it's a little bit green, but still eat the green part. Probably don't eat the whole thing. Dogs will do that, so leave it for the dog. If bubbles are formed, this is a great example for thinking about like brewing and fermenting processes or any sort of fermentation process. If you've ever made bread, then you'll see bread actually kind of rise because chemical reactions are taking place, because sugars are being broken down. The yeast that was used to make that bread is producing carbon dioxide, so the chemical reactions are taking place. And then, again, with the milk example, if there's a solid stink to it, well, a chemical reaction is probably taking place. Good. There's definitely like blurred lines between physical and chemical properties and physical and chemical changes. If a chemical change takes place, that's because something has a chemical property. It's also, those two things are very interwoven with one another. Deal? Okay, great. Now, classification of matter. We have our three major types: solid, liquid, and gas. We've got an example of a, what type of property is a state? What we're gonna do, because we're not all on Zoom, and those of you who are on Zoom, you do not have to turn your camera on for this, but play along with us. If you think that a state of matter is an A physical property, put your left hand up. If you think that the state of matter is a chemical property, then put both hands up and ride a roller coaster. Okay. On 3. Is the state of a substance a physical or chemical property? 1, 2, 3. You're right, it's a physical property. I wanted everyone to ride the roller coaster of enthusiasm, but I didn't construct it very well. Okay, so physical property, because think about a physical change. Helium gas going into a liquid, or if anyone's ever used liquid nitrogen or dry ice or something like that. Liquid nitrogen is N2 that goes from a liquid. What happens to liquid nitrogen? It vaporizes very quickly. What happens to dry ice? Well, it goes from solid to a gas. It's still the same material, it's just at a different temperature. So, states of matter, characteristics. Solids have a defined shape and a defined volume. These two things go hand in hand with one another. Liquids have an indefinite shape, but they have a definite volume. So if I were to take this bottle of water here, it's about halfway full. Let's call it 400 milliliters. 400 milliliters. If I were to pour it on this table, this sample of water is still going to be 400 milliliters. But what's going to happen to it when I pour it on this table? It's going to go everywhere. It's going to cover the table and go to the floor. Did I still pour out 400 milliliters of water? I did. The last one, a gas. And I always like to think of examples, specific examples. When I was in 6th grade, there was a classmate of ours who got a stink bomb. And she broke it in the bathroom. And then that stink bomb, which, does anyone know what I'm talking about whenever I talk about a stink bomb? They're little glass, they look like vials that you crack them and then they release a gas. And the gas smells awful. It's basically just the smell of rotten eggs. Well, she got that and she wanted to demonstrate everyone phase transitions. She was like, listen, it is a liquid. But as soon as I break this open, that liquid will transition to a gas. Physical change. Everyone got to learn it, so it's really great. I mean, she didn't tell anyone that, but that was the intent. So this liquid gets spilled out, it vaporizes. This happens in the bathroom early in the morning. Then that gas, what's it gonna do? Like if I cracked a smoke bomb in the corner here, what's gonna happen to it? Exactly. It's gonna fill the space that it's in. So, you know, if let's say that I got a box and I put that box over that stink bomb. The odor of that stink bomb is gonna fill that box. So the volume would be that box. But then if I lifted that box off, now the volume is gonna be the room that it's in. And when you have this is a sixth grade, so middle school, you have a duct system, an air conditioning system that connects every room to effectively every part of the school. When she broke that stink bomb off in the bathroom, that odor filled the bathroom. Then it started filling the duct system. Then it started filling all of the offices and all of the classrooms. And then we had a half day. It was one of the best days in sixth grade. And we learned all about gases having an indefinite shape and an indefinite volume. And at some point, what did they do? Well, they opened the doors to the school. What's going to happen to that odor? Well, it's going to go from being contained in the school to now being contained in the entire atmosphere. And so is that school going to stink very much anymore? No, it's going to be gone in about a day. And then we had to go back the next day. But we got a half day. It was great. Buses came, everything. It was awesome. Okay, so solids, I always think of a brick as a definite shape, definite volume. Liquid, indefinite shape, but a definite volume. If I poured 400 milliliters of water from this water bottle into a glass, well, that glass is going to have a different shape than this water bottle. So the shape is going to be different. The shape is going to be whatever the container that you pour it into. Gases, indefinite shape, indefinite volume. They're going to fill whatever they are given to fill. Is everyone good with those? Okay, now types of matter. All matter can be broken into two different major categories: substances or mixtures. Most of what we'll be doing is we'll be talking about mixtures in this class, basically from here on out. Mixtures are composed of two or more substances. So sodium chloride, table salt, is a mixture. Crude oil is a mixture. Now these mixtures can be one of two different things. They can be heterogeneous or homogeneous. Homogeneous, it's going to look the exact same throughout. Heterogeneous is going to look kind of different. I always think about, well, here we have examples of pieces of jewelry. Here we have gold or brass and silver. And then on the left-hand side for homogeneous, we have something that the mixture of it looks the exact same throughout. Is it multiple things? Yeah, it's brass. Brass is an alloy. It's a mixture of different metals. When we talk about substances, our substances fall into two different categories. They are either elemental substances or they are compounds. An elemental substance, indicated here with our Walking Liberty coin, that is a pure gold coin. That coin is not in circulation. Chances are it's sitting in someone's desk or something like that. If that was in circulation, if that was being used on a regular basis, any of the markings there are going to be worn down. Why? Because of the physical property that gold has of malleability. So it's going to get worn down. So your hierarchy. All matter is going to fall into substances or mixtures. Mixtures are either heterogeneous or homogeneous. Substances are either elements or they are compounds. Now, examples that I think are worthwhile to think about. Blood is a homogeneous mixture. It's got a bunch of stuff in there. But if you look at, if you look at blood and you keep it at like a stable temperature and everything, it's going to look composed the exact same throughout. A heterogeneous mixture would be something like if you go down to Galveston and you get a cup and you scoop into the water and you pick up some of the sand. Well, that sand is going to sink to the bottom because it's more dense. That liquid at the top, if you let it settle for a little while, it's going to look pretty much clear throughout. If you shake that up, it's going to be a heterogeneous mixture. If you let it settle, the water will become kind of a homogeneous mixture. Does that make sense? So it's almost like a given time, it will become a homogeneous mixture. Given in sort of interruption or shaking, it will look like a heterogeneous mixture. So an element is composed of one type of atom. So if you go and if you buy something that is gold, you are intending to pay for something that is pure gold. So that is made up of a single atom. It's lots of metallic bonds connecting lots and lots of these atoms of AU on the periodic table, which is G, AU. Right next to my finger. It's looking right at it. The ball hit me in the hands when I was trying to catch it. That was the problem. So gold is just a bunch of AU atoms. Oxygen is 2 O2 atoms. So this is, and we will get into this later on, so don't stress about this right now. But this is an example of what's called a diatomic element. There's a couple of elements on the periodic table that they don't exist as individual atoms like gold does, but instead they need another one of themselves to exist in solution. A compound is composed of 2 or more elements. Water is a great example of a compound, as is table salt, NaCl. Now, an atom is the smallest characteristic part of an element. So when we're talking about, and I will do my best to not do this, but sometimes I will use the terms atom and element interchangeably. Be careful when you're doing it. A molecule is composed of 2 or more atoms. Water is H2O. Carbon dioxide is CO2. Oxygen is O2. So when we look at this right here, molecule and compound. So water is a compound because it's composed of 2 or more elements. It's also a molecule because it's composed of 2 or more atoms. Oh. Okay. Does anyone have any questions? So what we're looking at now is a lot of categorization and classification. Using terms appropriately is basically what we're getting after right now. With that said, that's where I'm going to stop today's recording and stop today's lecture. And then tomorrow we will take off with chapter 6, or no, sorry, 1.6. I'm gonna stop the recording.